Hello friends, welcome to Thorough Education on the digital class platform. Myself, Mr. H.V. Kevadia, and today I am taking your chapter number 30, Surface Areas and Volumes. In this chapter, we will learn about different kinds of shapes, 3D shapes. So first, here I have written some short forms. A means area, V means volume, TSA, total surface area, CSA and or LSA means curved surface area or lateral surface area. These are some shapes. These are some short forms. Here are the shapes and their areas and volumes, the formulas which are required for our sums. Here it's a cube. LSA. Cube means all the sides are equal. All the 6 sides are equal. LSA, lateral surface area. That means all the area of all the 4 sides. 4 sides. Not top and bottom. Only 4 sides. That is 4 into L square. TSA. That means including bottom and top. That is 6L square. And volume of cube is L cube. Here cuboid. Cuboid is in this shape. So if we want to take LSA, that is 2 into H. LSA, that means area of 4 sides, not including these 2 sides. LSA means 2H into bracket L plus B, or we can say perimeter of a rectangle into height, that is LSA. And TSA, total surface area, that means 2 into LB plus BH plus LH. Here L is length, B is breadth and H is height. Similarly, the volume of cuboid is LBH. Here is cylinder. Cylinder has LSA 2 pi RH. 2 pi RH. Pi is a constant. LSA, that means curved surface area, not including top and bottom, only curved surface area, that is LSA, 2 pi RH. And TSA, including bottom and top, 2 pi R into bracket R plus H. If there is no top, only bottom, then TSA with only bottom is pi R into bracket 2H plus R. And volume of cylinder is pi R square H. Right? Here is the sphere. Sphere. Here it is TSA 4 pi R square, because there is no LSA at all. It's only in round shape. So TSA is 4 pi R square and volume of the sphere is 4 by 3 pi R cube. If it is hemisphere, then hemisphere, that means half the sphere. Half sphere. If we cut it down, then LSA, lateral surface area, the half of the sphere, that is 2 pi R square. And TSA, TSA means including surface of the cut, that means circle, that is 3 pi R square. 2 pi R square plus pi R square, that is 3 pi R square. And volume of hemisphere is 2 by 3 pi R cube, because it is 4 by 3 pi R cube. The volume of hemisphere is half the volume of sphere. Then comes cone. This is a cone. Here it is LSA, curved surface area, lateral surface area, pi RL. And TSA, TSA includes bottom, which is circular, that is pi R into bracket L plus R. And here L means what? Lateral means slant height. L is slant height. If we use Pythagoras, then here it will be L square equals to H square plus R square. This is formula of L. If we take only L, not square, then under root R square plus H square. Then volume is 1.3 pi R square H. Here volume of cylinder is pi R square H and volume of cone is 1 by 3 pi r square h. That means the volume of cone is 1/3 of the volume of cylinder. Here is the new shape which is known as frustum. Frustum of cone. If we cut this cone from here, it will be like this. Frustum. Right? Here it is R2, this is R1, that means there are two radius, and here is height h. So LSA equals to pi L. L means lateral height. Pi L into bracket R1 plus R2. This is only LSA. If we consider a glass, and TSA includes top and bottom with LSA. That means pi into bracket L R1 plus R2 plus R1 square plus R2 square. And L is, what is L? L is h square plus R1 square minus R2, R1 minus R2 whole square. This is our L, lateral slant height. And volume of this frustum is 1 by 3 pi h R1 square plus R2 square plus R1 into R2. This is volume. So friends, here the total formulas are given which come in this chapter. Now we are taking exercise 13.1. Here is the question. There are 9 questions in exercise 13.1. So first question is, two cubes each of volume 64 centimeter cube are joined end to end. Find the surface area of the resulting cuboid. Look at here, look at the figure. This one is one cube, this is the other cube. They are joined together. They are joined together. So what will happen? This is side 4, this is side 4, because it's a cube, and 64 is the volume, so L cube is 64, therefore L is 4. Here I have taken L4. Now what to do? 4 plus 4, this length becomes 8 centimeter, right? So L of cuboid is 4 plus 4, 8 centimeter, B 4 and H 4. Now we want to find out resulting cuboid. That means TSA equals to 2 into bracket LB plus BH plus LH. That means 2 into 8 plus 8 into 4 plus 4 into 4 plus 8 into 4. It will give us 2 into bracket 32 plus 16 plus 32. Here it is 2 into 80, which gives us 160 centimeter square. This is area, so we show it centimeter square. Question number 2. Let me read the question. Here is the question. A vessel is in the form of a hollow hemisphere. Vessel is in the form of a hollow hemisphere mounted by a hollow cylinder. This is hollow cylinder on which hollow hemisphere is mounted, right? The diameter of the hemisphere is 14 centimeter. This is the diameter. It is 14 centimeter. And the total height of the vessel is 13 centimeter. Height of the vessel 13 centimeter. So find the inner surface area of the vessel. Inner surface area, that means curved surface area of the cylinder plus curved surface area of hemisphere. That will give us inner surface area. Here we have taken height 13 minus 7, because total height is 13, and this radius is 7 because diameter is 14. Radius is 7. Here total inner surface area equals to CSA of cylinder plus CSA of hemisphere. That is 2 pi RH. We have seen the formulas, plus 2 pi r square. If we take 2 pi r common, then h plus r. Here it is 2 into 22 by 7, which is value of pi, into 7 into bracket 6 plus 7. Here 7 cut off, 22 2s are 44, 6 plus 7 13. Don't cut this 7 because this is in addition, not in multiplication. This will be cut off. Here 572 centimeter square is our answer. Question number 3. Question number 3. A toy is in the form of a cone of radius 3.5 cm mounted on a hemisphere of same radius. Toy. Here it is. This is hemisphere and this is cone. The total height of the toy is 15.5. From here to here, top to bottom, the height is 15.5 cm. Find the surface area. But the radius of hemisphere and radius of cone is given. So we will find out height of the cone. So radius is 3.5 cm and height is 15.5 minus 3.5. This will give us height of this cone. Now L square equals to R square plus H square. L square, that means R square, that means 3.5 square plus 12 square. 12.25 plus 144, that is 156.25. And now if we take square root of L, then we take square root of this. It will give us 12.5 centimeter. So lateral height, slant height is available. Now TSA of the toy. Slant height is available. TSA means LSA of hemisphere, this hemisphere, and LSA of cone, lateral surface area of cone. Now look, here it is 2 pi r square plus pi r L. Both have pi r common, then 2r plus L. Put the value, pi equals to 22.7 into 3.5 into 2 into 3.5 plus 12.5. Here it is 19.5. 3.5 into 2, that means 7 plus 12 19, and here it is 7 5s are 35, 0.5, and 0.5 multiplied by 22, which give us 11. So if we multiply both of these, we get here 214.5 centimeter square. Here friends, question number 4. Question number 4. A cubical block of side 7 cm is surmounted by a hemisphere. Cubical block is surmounted by a hemisphere. It is a cube and there is a hemisphere on the cube. What is the greatest diameter the hemisphere can have? Find the surface area of the solid. One is cube and one is hemisphere surmounted on the cube. Here I could not draw the figure. So the side of cube is 7 cm. Here it is given. And a hemisphere is surmounted on the cube. Therefore, the greatest diameter of the hemisphere is 7 cm. Right? The total surface area of the solid. Here I have given the first answer, 7 cm. Total surface area. TSA of cube. If there is a cube, then TSA. LSA of hemisphere, the above LSA. And area of the circle minus area of the circle, which is at the bottom of hemisphere. So 6L square plus 2 pi r square minus pi r square. Right? Minus pi r square. 2 pi r square minus pi r square, that is pi r square. And 6L square. 6 into 7 square plus 22 by 7 into 7 by 2, 7 by 2. Why 7 by 2? Because diameter is 7 and radius is 7 by 2. If we cut off this, then 7 cut off, 11 2s are 22 and 11 7s are 77 by 2, and here it is 49. Then 6 into 49, that is 294 plus 38.5. It gives us 332.5 centimeter square. One cube is there and hemisphere is put on the cube. This is the figure. Look at question number 5. A hemispherical depression that means bottom, that means cut out from the cube. Depression is cut out from one face of the cubical wooden block such that the diameter L of the hemisphere is equal to the edge of the cube. Determine the surface area of the remaining solid. Here the diameter of the hemisphere is equals to length of the cube, that means L. Here diameter is L, therefore radius will be L by 2. So surface area of remaining solid, that means if total surface area of cube plus LSA of hemisphere which is inside the cube minus area of the bottom circle, same as question number 4, same, but it is cut down and the previous one was above the cube. Here it is same formula, 6L square plus 2 pi r square minus pi r square, 6L square plus pi r square, that gives us 6L square plus pi into bracket L by 2 square, because L by 2 is the radius. Here L by 2 becomes L square by 4 because it is a square of whole bracket. If we take LCM 1 upon 4 L square as common, then 6 4s are 24, 24 plus pi, 1 upon 4 L square bracket 24 plus pi. This is our answer. We have taken L square by 4 as common. Question number 6. Here it is. A medicine capsule is in the shape of a cylinder with 2 hemispheres stuck to each of its ends. Look at the figure. Here it is a hemisphere and this one is another hemisphere. This is in the shape of cylinder. The length of the entire capsule is 14 millimeter. Length is 14 millimeter. And the diameter of the capsule is 5 millimeter. The diameter is 5 millimeter. So here it will be the radius and here will be radius. Radius plus radius gives diameter. If we subtract 14 minus 5, we will get the height of the cylinder. Right? Height of the cylinder. Radius is 5 by 2. The ends of capsule are made up of 2 hemispheres. Total area of capsule equals to area of cylinder plus area of 2 hemispheres. Then 2 pi RH plus 2 into 2 pi r square. If we take 2 pi r as common, then h plus 2r. It will give us h plus 2r. And here it is the value of different these constants. 2 into 22 by 7 into 5 by 2. 5 by 2 is the radius. Height is 9 plus 2 into 5 by 2. It gives us 11, that means 110 upon 7, because here 2 2s are, that means 2 1s are 2, cut. 22 into 5, 110 upon 7 into 14. Here also 2 2 cut, 5 plus 9, 14. 7 2s are 14 and 110 2s are 222. 220 millimeter square is the total surface area of the capsule, medicinal capsule. Now question number 6. Question number 6. Question number 7. A tent is in the shape of a cylinder surmounted by a conical top. Here is the figure. This is cylinder and this is conical top. If the height and diameter of the cylindrical part are 2.1 meter and 4 meter respectively, height and diameter, that means cylindrical part This is height 2.1 meter and diameter is 4 meter. And the slant height of the top, that means slant height of cone, is 2.8 meter. Find the area of canvas used for making the tent. We should find out total area of this cone as well as cylinder. Also find the cost of the canvas of the tent at the rate of 500 per meter square. Note that the base of the tent will not be covered with canvas because base is empty, there is no canvas at all. So what to find out? First, we are given here height of the cylinder 2.1, radius 4 by 2, that is 2 meter, and slant height of cone is 2.8 meter. Now TSA of the tent, that means LSA of cylinder, this cylinder, and LSA of cone. 2 pi RH plus pi RL. If we take pi r common, then 2h plus L. Put the value 22 by 7 into 2 into 2 into 2.1 plus 2.8. 2.1 into 2, that is 4.2 plus 2.8. It will give us 7. 7 cut off, and we have got 44 meter square. This is the total area of this tent. But we want to find out the cost. Look, the cost of 1 meter square canvas is 500 rupees. 500 it is given. The cost of 44 meter square canvas equals to 500 into 44 gives us 22,000 rupees. 22,000 is the cost of total tent canvas. Now question number 8. Question number 8 is, from a solid cylinder whose height is 2.4 centimeter. This is the cylinder, height is 2.4 centimeter and diameter 1.4. Diameter is 1.4. A conical cavity of the same height and same diameter is hollowed out. It is a conical cavity of the same height and same diameter. Find the total surface area of the remaining solid to the nearest centimeter square. Look at here. This is cylinder and this one is cone. Right? So if we find area of cylinder, then cylinder has a bottom and cone has lateral surface area. Right? So first of all, height of the cylinder and cone is 2.4 centimeter. Radius of the cylinder and cone is 1.4 by 2, that is 0.7 centimeter. Now first we have to find out L. L square equals to R square plus H square. We have found out L equals to 2.5 centimeter. Right? L equals to 2.5. Now take the area of remaining solid, that is TSA of cylinder plus LSA of cone. TSA means this lateral surface area and bottom, that is 2 pi RH plus pi r square plus pi RL. Pi RL is the area of cone. Here I have taken pi r as common because radius is same in cone and cylinder. Then 2h plus r plus L. Put the value 22 by 7 into 7 by 10 because 0.7 is the radius. 7 by 10. 2 into 2.4 plus 0.7 plus 2.5. Right? Here 2 into 2.4, that is 4.8, and 7 cut off, it is 2.2, and we have got here 8. 8 into 2.2, that is 17.6. But we are given find area in nearest centimeter square. Then 7.6 is nearest to 18. 17.6 is nearest to 18. So we have found out here 18 centimeter square. Question number 9. Here is the question. A wooden article was made by scooping out a hemisphere from each end of a solid cylinder as shown in the figure. If height of the cylinder is 10 centimeter and its base is of radius 3.5 centimeter. Find the total surface area of the article. Friends, see the figure in the textbook. Radius is given 3.5 and height is given 10. So total surface area means LSA of cylinder plus 2 into LSA of hemisphere, because there are two hemispheres at both the ends. So LSA of cylinder 2 pi RH plus 2 into 2 pi r square. This is 2 pi r common, then h plus 2r. Here put the value 2 into 22 by 7 into 3.5, which gives us 10 plus 2 into 3.5, that is 22 into 17, because 7 5s are 35, 0.5 into 2, that is 1 into 22 is 22, and if we do multiplication, 3.5 into 2, that is 7 plus 10, 17. If we multiply both 22 and 17, we will get 374 centimeters square. These are the sums we have completed exercise 13.1. Friends, if you have any doubt, then watch the video again and again, and I can say thank you for watching my video and thank you for being with Toral Education. Thank you very much.